Well, today we are going to practice a mole to mole conversion. So it's moles of one thing to moles of something else. Moles of A to moles of B. Don't forget we abbreviate moles MOL. Alright, so the first thing we need is a balanced chemical equation. This one does not appear to be balanced. So what I'm going to do is make a list. So this is also then a review of balancing. I'm going to count how many things I have on each side. I'm making a note to myself that I have oxygen in 2 places. So 2 of the oxygen here plus the 1 oxygen here makes 3. 2 hydrogens, and then on the other side I have oxygen in 2 different places also. Okay, so to begin with, what I am going to do is I am going to put a 2 in front of my NaOH, my sodium hydroxide. That's going to give me 2 sodium and 2 hydrogen, then 2 oxygen that are here, plus the 2 that are over here. Now that gives me 4. Then the next thing I'm going to do is put a 2 in front of my H2O. So now that gives me 4 hydrogen and 2 plus 2, 4 oxygen. So that equation is not quite balanced yet because my hydrogen is not balanced. So now what I'm going to need to do is use a little bit of whiteout because I didn't use a pencil. I'm going to change the number in front of my NaOH to a 4. So now I have 4 NAs, 4 plus 2, 6 oxygen, and 4 hydrogen. So now I need to go over here and put a 2, which changes my NAs to 4 because 2 times 2 is 4. So then I also have 4 oxygen plus the 2 oxygen that are here. So now I have 6. So this equation is now balanced. And I know that when I do mole ratios, I need to use the coefficients. So I'm just going to remind myself where those coefficients are by using the rectangle shape, which is the same shape that I show you guys when I work the problems. So let's start with a problem. So if you are given 4.96 moles of water, how many moles of oxygen gas can be made? Okay, so keeping that balanced equation in our window of view, let's go ahead and start with what we're given in the problem. And then I like to circle what I'm trying to find. That gives me, again, those visual clues so that each time I do these problems, I know what to do. So 4.96 mole of H2O, and I'm building a picket fence. I take this label and I put it on the bottom right because I want that label to go away. Remember, that step is always the same. So if I have moles of water on the bottom and I'm trying to find moles of oxygen, I can definitely put those 2 things together because this is a mole ratio. When I have moles per mole, that is a mole ratio that comes from the balanced chemical equation. So in front of O2 I have a 1. In front of H2O there is a 2. Moles of H2O crosses out, and so now I'm left with moles of oxygen, which is exactly what I am trying to find. So then in my calculator, I am going to put in 4.96 divided by 2 equals 2.48. Why did I divide by 2? Because whatever's on the bottom is what you divide by. Whatever is on the top, you multiply by. Why didn't I multiply by 1? Well, because it gives me the same answer. So my original data had 3 significant figures. That's looking back into the problem. My original data, 3 sig figs. So then my final answer needs 3 sig figs, which it has.